Traditional Big Bang Theory states that the entire universe exploded from one tiny point of infinite density. Since that time, it seems to be expanding, getting bigger. And this theory is very well accepted. After all, it explains the cosmic background radiation and the development of light elements. However, the theory has faced many challenges. Let's look at some of these challenges. Then let's look at the inflation theory, a theory that might be able to help us overcome some of these challenges. Challenge 1. The flatness problem. According to the Wilkinson Microwave Anisotropic Probe, or WMAP, the geometry of the universe is pretty much flat. The traditional Big Bang Theory implies that the universe is expanding into something, like a balloon does into the space around it, indicating that it's round or oval. A universe as flat as we see it today would require an extreme fine-tuning of the conditions of the past. Getting the fine-tuning just right would be an unbelievable coincidence. Challenge 2. The monopole problem. Monopoles are a hypothetical particle that may be loosely described as a magnet with only one pole, only positive or only negative. Big Bang cosmology predicts that a very large number of heavy, stable, magnetic monopoles should have been produced in the early universe. Unfortunately, magnetic monopoles have never been observed, so if they exist at all, they're much more rare than the traditional Big Bang theory predicts. Challenge 3. The horizon problem. Sources put the size of the universe at anywhere from 28 to 98 billion light-years across. Yet the oldest galaxies we see are 13.8 billion years old. So the edges of the universe are so far apart from each other, it seems they never could have been together. However, the temperature of the universe is uniform, implying that it all was together at one point. In short, how can we know that the universe is 98 billion light-years across, but the oldest galaxies we see are 13.8 billion years old? So these three problems, the flatness problem, the monopole problem, and the horizon problem, can be solved with something called inflation theory. The inflation theory was developed by Alan Guth, Andre Linde, Paul Steinhardt, and Andy Albrecht in the early 80s. It offers solutions to these problems and several other open questions in cosmology. You can sum the theory up by saying 10 to the minus 36 seconds after the Big Bang, there was a period of exponential expansion. This expansion was of space, not matter. So the Big Bang wasn't just a bang of matter, but it was a big bang of space. And it is space that's been expanding ever since. So let's see how the inflation theory can help dispel some of the challenges the traditional Big Bang theory faces. The flatness problem. Imagine living on the surface of a soccer ball, or a two-dimensional world. It might be obvious to you that this surface was curved and that you were living in a closed universe. However, if that ball expanded to the size of Earth, it would appear flat to you, even though it's still a sphere on larger scales. Now imagine increasing the size of that ball to astronomical scale. To you, the horizon would look as flat as a pancake as far as you could see, though it might have been very curved to start with. So inflation stretches any initial curve of the three-dimensional universe to near flatness. The monopole problem. Inflation allows for magnetic monopoles to exist as long as they were produced prior to the period of inflation. During inflation, the density of monopoles drops exponentially, so their abundance drops to undetectable levels, which is why we may not be able to see them today. The horizon problem. Remember, the bang of the Big Bang wasn't a bang of matter, but a bang of expanding space. Space is not bound by any of Einstein's laws of relativity. Therefore, it can travel faster than the speed of light. This allows the edges of the universe to be 98 billion light-years across, even though they were together 13.8 billion years ago. So despite the challenge the traditional Big Bang theory faces, Inflation allows us to overcome these challenges. Adding inflation to the traditional Big Bang theory allows it to now be accepted by most scientists.
Our whole universe was in a hot, dense state that nearly 14 billion years ago expansion started. Wait, the earth began to cool, the autotrophs began to drool, Neanderthals developed tools, we built a wall, we built the pyramids. Math, science, history, unraveling the mystery that all started with a Big Bang.